Alright, how's everybody doing today? This is Mr. Muscarella coming at you. And in this video, I'm going to show you about writing domain restrictions for trigonometric functions. Now, one of the things you've got to be familiar with is this thing called the set of integers. And the set of integers is basically any whole number that is positive or negative. So what that means is that there are no decimals or no fractions that wouldn't reduce to or be equivalent to any integer. Now this symbol that you see here in the bottom, this Z with the kind of extra line through it, that's a symbol that math people use to represent the set of integers instead of saying the set of integers. So for shorthand, we'll go ahead and use this symbol Z when we're referring to the set of integers. Now there's a couple things you've got to know about counting. Now anytime you want an even multiple of something, what you're going to have to do is just multiply that number by 2, whether that number is odd or even. If you multiply an odd or even number by 2, you'll end up with an even number. Now that's going to be represented by this, 2k, where k is an element of z. So that funky little symbol that's right next to the z, that means is an element of. So for even multiples, that's the expression that you would have. Some textbooks use the letter n, others use k, but that's the general idea of how you would write that. Now for odd multiples, anytime you need to get an odd multiple, well, if we know that for an even multiple, we would multiply something by 2. To get an odd multiple, we would do the same thing, but then add 1. So that's going to look like this, 2k plus 1, where again, k is an element of the set of integers. So that is what you're going to have to make sure that you know for this section, because we're going to deal a little bit with even or odd multiples when we come to domain restrictions. So let's go ahead and take a look at 3 examples real quickly here until we take a look at a couple of graphs. Now for this one, we want odd multiples of pi over 2. So say you graph something or you're solving a trig equation and your domain restriction, you notice that, well, any odd multiple of pi over 2 does not work, meaning there's an asymptote there or our function's undefined for that section. So when you do that, now we've got an odd multiple, so that would just look like this. You would say x is an element of the real numbers. So that funky symbol with the r, that just means all real numbers. So x can be any real number except 2k plus 1, because that's the odd multiple part, and then pi over 2. But then you have to state that k is an element of the set of integers, which is represented by k and then the element symbol and then the symbol for the set of integers. That's all there is to it. Some textbooks will use n, some will use k, but you get the general idea with that. Now for odd multiples of pi over 4, it's going to be the same idea. If your domain restriction is anything except for an odd multiple of pi over 4, it'll look almost exactly the same thing as the previous one, except where the pi over 2 is, we're going to have pi over 4. Now by now I think you have it. If we had odd multiples of pi over 3 in our domain restriction, where x could be any number except an odd multiple of pi over 3, then you would just represent that like this. So that's a little bit about representing domain restrictions for odd multiples of different trig functions you'll probably come up with. Now let's take a look at a couple of graphs to make sure that we've got this down. Now here's our first picture. I don't know if it's a tangent function or a cotangent function. I'm not really sure, but I've got to be able to count, because counting is key. Now one of the things that we're going to take a look at is where all of my asymptotes are. I've got one right here at pi over 6. Now my next spot is going to be 2 pi's over 6, but of course you don't leave it like that. You can see here in the graph it's reduced down to pi over 3. But then the next one would be at 3 pi's over 6, and then I'd have 4 pi's over 6, which we end up reducing down to 2 pi over 3. Then there's another asymptote at 5 pi over 6. If I look on the negative side, I have an asymptote at negative pi over 6, and then at negative 2 pi's over 6, I have no asymptote, but again, that's reduced to negative pi over 3. But then I have another asymptote at negative 3 pi's over 6, which reduces down to negative pi over 2. So I think you get the general idea of that. Now, if that's what we've got to work with, then our domain restriction looks like if I take out all of the functions or all the values where I don't have an asymptote, look at what we've got here. I've got all these odd multiples of pi over 6. Because I have 1 pi over 6, 3 pi over 6, 5 pi over 6, negative 1 pi over 6, negative 3 pi over 6, negative 5 pi over 6. So I've got all the odd multiples of pi over 6. So to go ahead and represent that using correct notation, set notation, would just simply look like this. See, so that wasn't too bad. X is an element of the real numbers, such that x can't be 2k plus 1, that quantity, times pi over 6, where k is an element of the set of integers. Alright, so that's one way to represent that. Now I'm going to give you one, because I think you guys probably have this down pretty much. I'm going to give you one to try on your own. Check out this picture. Now here's the last example I want you to take a look at. First thing you've got to be able to do, because this is going to be secant or cosecant, I'm not really sure, and I don't really care because I just want to come up with a domain restriction already. Gosh! So here we go. Check it out. You got to be able to count to see where each one of the tick marks are. So we've got multiples of pi over 4. It looks like this scale on this is by pi over 4 along the x-axis. So if you notice, you can kind of pick up where the asymptotes are going to be. Try this one on your own and see if you can come up with a domain restriction for this function. When you think you got it, then let's come on back and see how you did. Alright, so how'd you do with this one? Did you correctly come up with a domain restriction that x can be any number in the subset of real numbers with the exception of multiples of pi over 2? Hopefully you were able to deduce that all of the asymptotes were at multiples of pi over 2. And that would look like this, which is shown here at the bottom of your screen. That's it for this video. Thanks for watching, boys and girls, ladies and gentlemen, and everybody else out there in YouTube land. By now, you should be able to write domain restrictions for any of the trig functions. Thanks for watching, and you guys have a great day. Peace out.